Good morning. The next module will be discussing about the control components in case of hydraulic systems. Right. So the control components are nothing but are the devices with the help of which we are controlling the various parameters, such as I can control the direction, I can control the pressure, as well as I can control the flow. Based on these classification, we are categorizing them into DCV, PCV as well as FCV. Let us see in detail about these classification. The direction control valves are used in order to control the direction of the fluid flow. In which direction I want the fluid that has to be moved. So the direction of the fluid is going to control again the extension of the cylinder or the actuator, the retraction, the positioning as well as the reciprocation. So various application can be taken out from allowing the fluid to pass through in one direction or in the another direction. So the amount of fluid, the direction of the fluid what you are supplying, that may be done with the help of various ports that can also be called as the ways. Right, let us see in detail in the coming slides. So the classification, the main classification whatever we are doing in the case of direction control valve is according to the type of construction. We are classifying it as a the puppet type of valve as well as the spool type of valve. Right, so these are the two classification what we are doing based on the construction. Similarly, based on the number of working ports, right? Either I will be using the two-way, that means in each position I will be having only two positions. Sometimes I may be having the three positions, that may be one here, one system port here, and the tank port here. Sometimes even I may be having the four in each positions. These two are the system ports and this is the pump port and this is the tank port. Right? So depending upon how many number of ways or the ports we are using in each position, we are classifying it as two-way, three-way as well as four ways. With the help of switching positions means each square block is going to represent a one position. If I am using two square blocks which are attached side to side, then it is called as two position. This is called as the first position, this is the second position. Similarly, if I am having a one more square block which is attached here, this is called as the third position. Right. So based on the switching positions, they have classified it as a two position as well as three position DCBs. And in order to actuate these switching positions, I may be having a certain mechanism that is called as actuating mechanism. In order to actuate first position, I need to operate this actuating system. This may be a push button, that may be a mechanical lever, or that may be a solenoid, or that may be a hydraulic pilot. Right. So if I filled it with the help of a completely filled triangle, this is for the hydraulic actuation. If I just show an empty triangle, this is for the pneumatic actuation. And along with this one, if I am showing with the help of cross mark, it is indirect actuation. Right. So in the coming classes, we will see in detail about these actuating mechanisms. So the first direction control valve, what we are going to discuss is about 2 by 2 direction control valve. Right. So the first two representing the number of ways or the number of ports, and the second two represents the number of positions. Right. So this is the symbolical representation. This is the symbolical representation of 2 by 2 direction control valve. Right. So in each positions we are having two ports that is pump port as well as system port A, that is in the first position. Similarly, in the second position also we are having two ports, that is pump port P and system port A, right? But in the first position the pump flow is connected to system port, whereas in the second position the pump port as well as the system port is completely blocked, right? So in order to actuate this position, I may use a mechanical lever in order to actuate the first position. If you won't actuate the first position, automatically it will go for the spring return position. That means the second position, right? So that is in the case of 2 by 2 direction control valve. The next one is the 3 by 2 direction control valve. This 3 is representing the number of ways. How many ways we are having? That is pump port P, tank port T as well as system port A. Here also you can see three ports only in the second position, that is P, this is T and this is A, right? So three service ports we are having and two positions, right? So this is the first position and this is the second position. The same thing again, I will be using a solenoid here in order to actuate the first position. If I won't give the voltage to this solenoid, then obviously it will go for the spring return position in which the pump port is completely blocked, right? Whenever the pump port is completely blocked, then obviously we should go for compulsorily using the pressure relief valve, right? So in case of all the hydraulic systems whatever we are using, those are using the positive displacement pumps. Because of this reason, you should compulsorily use the pressure relief valve in order to safeguard our hydraulic systems. Okay. So the next type of valve is, that is 4 by 2-way valve. This 4 is nothing but again the number of service ports such as pump port, tank port, system port A as well as system port B. Right. So two positions here. This is the first position and this is the second position. Right. So in the first position, if I actuate with the help of a mechanical lever again, the pump flow will be circulated to system port A and the fluid which is coming from the system port B will be circulated to the tank, right? But in the second position, that is in the spring return position, the pump flow will be given to what? That is given to system port B, whereas the fluid which is coming from the system port A, that will be again circulated back to the tank, right? So this is in the case of 4 by 2-way valve. Similarly, 4 by 3-way valve, here we will be having four positions, that is four service ports and three switching positions, right? So you can see here the first position, the second position as well as the third position, right? So I can actuate the first position by using some actuating mechanism here. I can actuate this one also by using another mechanism. If you won't actuate the third position as well as the first position, automatically it will go for the second position, right? So especially it is the open center position. The central position is open where the flow will be taking place from either from P to A or P to B or P to T, right? The fluid flow will takes place where there is a least resistance, right? Right. So the next type of valve, the important or the basic valve which we are using in the case of hydraulic system is the check valve. Right. The check valve is also called as the puppet valve, or I can also call it as one-way valve. Right. So it will allow the fluid to flow in only one direction, not in the another direction. Right. So this is the symbolical representation of a one-way valve or a check valve, right? So the free flow will be taking place whenever that is taking place from A to B, whereas there will not be any flow from B to A, right? That means in only one direction the fluid flow is allowed, right? So this is the schematic representation of the wall, check wall. It is consisting of the ball or the puppet, right? It is consisting of the ball or the puppet, which is backed with the help of the spring force, and it is consisting of the two ports, the pump port as well as the system port A, right? So the first diagram indicates the valve is in a closed position. That means you are allowing the fluid to flow from pump to, system port A to P port. Right? Already we are having the spring force here, which is making the ball or the puppet to sit in the seater. This is called as the seater, right? So already we are having the spring force which is making the board to sit in the seater. Along with that one, we are having the fluid pressure also, so that again it will be tightly held in the seat itself, so that there will not be a flow from A to P, right? But but in the case of the second diagram, whenever the pump flow or the pump pressure is more compared to this spring force then obviously the ball will come out of the seater. That is nothing but the ball will move in the upward direction, so that I'll be getting the path to flow the hydraulic fluid from the sideways, right? So from here the fluid flow will be taking place from the side of the ball. This is in the case of the check valve, but the reverse is not possible here. Right. So as I said, we are having the two type of check valve. Whenever we'll be using the ball, this is called as a ball type of check valve. Whenever we'll be using the conical comb, right? So that is called as the puppet type of check valve, right? So I can get the flow from inlet to outlet, right? So because whenever this pressure will be more compared to this spring pressure, then obviously the puppet will come out of the seater. Then I will be having the gap which will be shown with the help of arrow mark here, right? So with the help of this arrow mark, along with this arrow mark, the fluid flow will be taking place and I will be getting the flow at the outlet. But from here to here, from outlet to inlet, which is not possible, because already we are having the spring force here. Along with this spring force, the some hydraulic energy is also going to be acted on the puppet, so that the puppet is tightly held in the seater, so that there will not be any flow. Some of the advantages as well as the disadvantages we are having. The advantages are no leakage, as it provides absolute sealing. Because of the tight sealing, we will not be getting any leakage. Right. The longer useful life, as there is no leakage of the oil flow, and it may be used even with the highest pressure, as no hydraulic sticking. Right. So there will not be a hydraulic sticking, because of which even it can operate at a highest pressure. Some of the disadvantages also we are having: the larger pressure losses due to the shorter stroke, where the movement of the puppet as well as the block will be taking place in a shorter manner, because of which there will be a larger pressure losses. Right. So along with this one, the pressure collapse will be done during switching phase, right, which is due to the connection of the pump as well as the connection of the pump actuator as well as the tank at the same time. That is the one more disadvantage we are having in the case of this type of direction control valves. The next type of direction control valve is pilot operated direction control valve. It can also be called as pilot operated check valve, right? So this is the graphical representation or the symbolical representation. It is nothing but the extended version of the check valve whatever we have discussed previously, right? So initially we will be having the flow from left to right, but in order to get the flow from right to left, I need to give the signal which is indicated with the help of dotted line here, right? So this is nothing but the polite signal. When you give the polite signal, then even the flow will be taking place from right to left. Right. So this is the schematic representation, which consists of the larger piston. This is the larger piston and this is the smaller piston. Both these pistons are connected with the help of a single connecting element. This is the single connecting element and this is the port through which you are supplying the polite signal. Right. That may be a hydraulic oil pressure or that may be a compressed air pressure. Right. So initially the flow will be taking place from this A port to B port. This is the system port A. Initially the flow will be taking place from A to B. This is nothing but the free flow direction. Right. How the free flow will be taking place? Because of the increase in the pressure which is acting from the top side, right? The pressure which is acting on the top side will make to move the piston in the downward direction, right? So it is opposing the spring pressure whatever we are having here, right? Because of that high pressure the piston will move towards downside, because of which when the piston reaches this particular point I'll be having enough space to move the hydraulic fluid from A to B. I'll be having enough space from A to B, right? But the reverse is not possible here because already the larger piston whatever we are having that is seated in the seater. Along with that one, if we are allowing the more amount of fluid to be acted from the bottom side, then again it is tightly held in the seater itself, right? So in order to get the flow from B to A, what I need to do? I need to apply the polite pressure here, right? So assume I will be applying the polite signal here on the polite pressure. So this makes the smaller piston to move downward. That means the larger piston is also going to move in the downward direction, right? So downward direction means once the piston reaches this position, then you allow the hydraulic fluid to flow from B to A, right? So initially the free flow will be taking place from A to B. Now after applying the polite pressure, the flow will be taking place even from B to A. That is nothing but in both the direction I will get the flow, but that is subjected to some condition. That is nothing but the application of the polite pressure. The next type of valve is the shuttle valve. So in this shuttle valve we are having the two inputs and one output. Two inputs and one output. So it consists of a one valve which will be moving between the two locking agents. These are called as the locking agents of the seater. In between these two seaters only the ball will be moving. So assume I will allow the fluid to flow from the pump P1 as well as the pump P2. Now which pump flow I will be getting at the outlet, either from P1 or P2. That depends upon again whether P1 is greater than P2 or P2 is greater than P1. If P1 is more compared to P2, that means the fluid pressure whatever we are pumping from pump P1 is more compared to P2 pressure, then obviously the pressure, this P1 pressure is going to make to move the ball towards the right side. That means it will be seated in the seater, so that I will be getting enough space in order to flow the hydraulic fluid from P1 to A4. Similarly, when P2 is more compared to P1, then the ball will be moved towards left side. That will be seated in the left side seater, so that I will be getting enough space to move the hydraulic fluid from P2 to A1. Right. So such type of valves are used whenever we are having two pumps. Whenever we are having the two pumps, whenever the first pump will be malfunctioning, in that case obviously the secondary pump will be coming into picture, right? That is in the case of emergency, we'll be using such type of valves, right? So this is the symbolical representation of the shuttle valve, which is consisting of the two inputs P1 and P2 and one output. And this is nothing but the seater, and this is the ball, or single ball, what we are moving from one seater to another seater. This is about the shuttle valve. Next type of valve is the spool type of valve. What is this spool? The spool is nothing but the connecting element between the two spool lands. Right? I can call this one as a spool, and this is called as the spool land. Right? The spool lands are used mainly in order to close as well as in order to open the ports, various ports, right? Either it may close the pump port or it may close the system port A. In order to close as well as in order to open the various positions, we are using the spool as well as the spool line, right? So the spool again, which is coming from the direction control valve, will be actuated with the help of the different actuating mechanism, right? So let us consider the first position. In the first position, there will not be a flow taking place from pump port to system port A, right? So we can see in the symbolical representation also, right? So in this position, the pump port is also completely blocked as well as the system port is also completely blocked. That means that we are not applying the pressure here. We are not actuating the first, we are not actuating the first position, so automatically it will be in the spring return position. In the spring return position, there will not be a flow because the pump flow whatever we are supplying, that will be obstructed with the help of this spool land itself, right? Because of which there will not be any flow taking place from P to A. But when you apply the pressure here, when you actuate the position, when you actuate the first position, the flow will be taking place from pump to system port A. That means the force whatever we are applying on this spool, that makes the spring to be compressed, right? Once the spring is in a compressed stage, then obviously there will be a path which is indicating the flow from pump port to system port A. This is in the case of 2 by 2 valve. As we are having the two positions, it is first position as well as the second position, as well as in one position we are having two ports, that is A port as well as P port. Similarly, in the case of three-way direction control valve, we are having the three positions. We are having the three ports and two positions. Right. So let us see in a symbolical representation. In the zero position, the pump port is completely blocked, as we can see here in the symbolical representation, whereas the flow will be taking place from system port to tank port, right? You can see here the pump port is completely blocked with the help of what? With the help of this spool land, right? So this spool land is making the obstruction in order to flow the hydraulic fluid from P to A, right? Whereas I'll be having the opening from A to T, right? So this is nothing but A to T. I'll be having the flow. So this is in the zero position. In order to actuate the first position, I need to operate this mechanism. I need to operate this lever. Once you actuate the first position, then there will be a flow taking place from P to A and the T port is completely blocked. That means there will be a flow which is taking place from P to A, whereas the T port is completely blocked with the help of what? With the help of this spool line, right? That is after actuating the first position, right? So this is in the case of 3 by 2 direction control valve. Similarly, the four-way direction control valves, which uses the four ports of the ways, and it uses the three positions. So the right envelope I will be having, and similarly the left envelope. What about the center one? Depending upon the various configurations of this 4 by 3 direction control valve, I can classify it as a open center, closed center, a tandem center, regenerative center, as well as the floating center. Let us see one by one these things. So this is the pictorial representation, and this is the graphical symbol of 4 by 3 direction control valve, which is of open center, right? So this is a parallel connection that is in the first position, and in the second position the flow will be taking place in a crossed manner, that is from P to B as well as A to T. But in the center position I am not having any obstruction. Instead, the pump flow can be connected to A, or it may be flow to B, or it can flow to even T also, right? So depending upon the system which is having the least resistance, that path will be taking place, right? So either the pump flow may be supplied to A, B or T. As the rule we are having, the flow will be taking place from a higher pressure to the lower pressure. That means from higher resistance to the least resistance. So in the central positions, you can see in the diagram here, in the central position the flow will be taking place either from P to B or from P to A, as well as from in this manner as well as in this manner, right? Which is having the least resistance, that path will be taking place, right? So this is in the case of open center, right? So these are the, this is nothing but the first position. In the first position the P is connected to A and B is connected to T, right? That means the pump flow will be supplied to A, and from system port B, that will be the fluid flow will be taking place from B to T. So similarly in the second position, the pump port will be connected to system port B, and the system port A is connected to tank port, right? So this is in the parallel as well as the cross connection of the 4 by 3 direction control valve. The next center is the closed center. In case of closed center, all these ports are in a blocked condition, right? So all these four ports are in a blocked condition. That means either I will be not connecting the pump port to B, or I will not be connecting to T as well as to A, right? All the ports are in a blocked condition. That means the piston whatever we are using, or the actuator whatever we are connecting to this direction control valve, is under completely locked condition, right? So in this locked condition I want to safeguard my hydraulic system, so that what I will be doing, I will be connecting this one to the pressure relief valve, right? So over the pressure relief valve only the hydraulic fluid will pass, again it will be flown to the tank. That is in the case of closed center. The next version of the closed center is tandem center. That is, the load whatever that was acting in the case of closed center, that one I am going to eliminate by connecting the pump port to the tank port, right? So you can see here the pump port will be connected to the tank port from either from this side or from this side, whereas A as well as the B ports are complete in a blocked condition, right? So this is happening in the case of tandem center. The same application I can use for hydraulical locking, that is the piston whatever we are using, that will be in a stationary position, because either I am not supplying the fluid from A, or I am not taking the fluid from the actuator, right? The piston will be in a static position. Next one is a regenerative one. Regenerative means we are taking the fluid from the system itself, from the same system itself. It is mainly used whenever you need the actuator movement at two different speeds, right? So at two different speeds, whenever you need that such type of application, you can use these types of regenerative center type of 4 by 3 one, right? In this case, what we are doing, we will be connecting the hydraulic fluid which is coming from the rod end side again to the pump flow, right? So we will be having the as usual flow which is taking from P to A, right? So along with this q amount of fluid, we will be adding some more amount of fluid which is coming from the rod end side. So the amount of fluid which is acting on the blind end side will be more, so I'll be getting the more velocity during forward compared to the reverse, right? So that is in the case of regenerative type of the 4 by 3 waveform, right? So as usual it will work, but the only advantage is I can get the two different speeds for this type of DCV. Next one is the floating center. In this floating center, we will be having usual flow from either B to T or A to T, but along with this one, the another port is also connected to T itself, right? We can see in the pictorial representation here, right? So this is for the mid position. In the mid position, the pump port is connected to T as well as the A port is also connected to T, whereas the pump port is completely blocked, right? You can see here the pump port is completely blocked, right? So such type of floating center 4 by 3 way direction control valves we are using whenever we need the free movement without any external force. Whenever we need the free movement of the actuator without application of the external force, in that case we can go for using this such type of floating center 4 by 3 way direction control, right? So these are the various configurations what we are having in the case of DCVs, 4 by 3 DCVs. The next type of valve is 4 by 2 direction control valve. Here we are having only two positions, either a first position or the second position, either the parallel connection of the fluid or the cross connection. Right. In the first position, the flow will be connected, that is the pump flow will be connected to system port A, and the system port B is connected to the tank port, right? You can see here this is the pump flow which will be connected to system port A and B will be connected to T, right? Whereas in the second position, that is in the crossed position, the flow will be taking place from pump to B and from A to T, that is after actuating the second position, right? So this is all regarding the various types of the direction control valves which we are using in the hydraulic systems. Thank you for watching.